We have coal that's in Ziplocs. We have sulfur that's in Ziplocs. We have some kind of silver of like aluminum foil. We have copper wire. We have aluminum wire. So, you know, that's what's concrete. That's what you teach with first before they ever learn about metals. And then what are the properties of those? Well, it seems that they're shiny. They conduct electricity, yada, yada. Then we name them as metals. Yes?
I have this PowerPoint printed for them. Do you want me to pass it out?
Yes, that's the real one I wanted. It doesn't exactly match this one. This is the better one. This is the one that goes with the videotape that I made. The other thing that's up here is bring in live plants. Don't do keying or other kinds of instruction with pictures. Remember, pictures are not concrete. They're pictorial, right? So use real things and have your students go out there and give them to collect them to use from.
So when school boards decide that they cannot, they tell teachers that they can't have live animals in the classroom, that's really pretty much shutting down learning.
Well, it certainly inhibits it a great deal, and I will actually be going to that school board and making that argument that there is no scientific, there's no data, there's no safety data that says you should not have animals in the classroom, with some exceptions like poisonous snakes.
That's awesome, thank you.
You can't have poisonous snakes in a room?
Pardon?
You can't have poisonous snakes in a room?
No, Tim.
It's a good thing I hired you.
We're in trouble because we're the rattlers.
Okay, the last thing is one concept per lesson. The TEKS often have more than one concept in science. I don't know about math, but
They
I would
do.
suspect, okay. You cannot teach, we cannot learn more than one concept per lesson well. So you may just choose one of these. It may be a 15-minute lesson, and then another 15-minute lesson, but it's still one concept, they learn this, then the next concept, they learn that, and the next concept, so you're scaffolding that instruction. If you try to teach too many concepts in one lesson, I can tell you, we go into classrooms and those kids they're lost, and then they give up, and then they're misbehaving, and it's our fault because we're not following fundamental principles like this. Okay, I'm not going to go into that, because I'm going to put that on the website. Okay, so the last thing that we want to do very quickly are the observations, the things that we learn from being out in your classrooms. Okay, this was, we were out in Tim's class, no, we were out in Brenda's classroom. So Brandon, you ready? This is math stuff here. All right, so we were out in Brenda's classroom, and about half of the students did not know orders of operation. Brenda, what course was this?
Algebra 1.
Algebra 1. Almost half of the students did not know order of operation.
It's not so good.
No, it's not so good. And what does that tell us is, K-8 in terms, right? So you want to do the doing, undoing part here?
Yes, so she was solving 1- and 2-step equations, and she had written addition and subtraction symbol, multiplication and division symbol there, and talked about the order of operations, and how when you simplify an expression, that's what you use. And then she said, I don't remember what word she used, but she either said flip it or reverse it. I believe she said flip it. Because when you're solving an equation, you would do it in the opposite order, because you want to undo what that equation is doing. So if you have 3x plus 2 equals 10, instead of doing the 3 times the x, because you can't, because you don't know what x is, you would add that -2 to both sides, so you're undoing the addition and subtraction before the multiplication and division, which is the reverse, the board of operations. So they had that visual on the board, which was good. And then she worked through several examples. I do want to tell you, doing and undoing is one of those algebraic habits of mind that you should be developing in your math kids. There's 3 algebraic habits of mind: doing and undoing, which includes anything that reverses or vice versa, or whatever you want to call that, such as addition and subtraction, undo each other, multiplication and division, undo each other. There are two operations in calculus, I can't remember their names. One is integration, and the other one starts with an E. And maybe, and they undo each other, okay? So doing and undoing is important. The second one is writing functions writing rules to represent functions or something like that, which we were going to do today, which we didn't get to, but we will get to next time we're together. And then the third one is abstracting through computation. Abstracting through computation. And that one I'll have some examples the next time we're together as well. So those 3 algebraic habits of mind we'll be working on the whole time we're together. And then there's 4 geometric habits of mind that we were going to get to today, but we'll do that next time.
When we go out to your classrooms, we try to schedule it so you've got time afterwards and we can sit down and do debriefing. When I'm going into a math classroom with Brownie, she's looking at the math. I'm sitting there trying to think, okay, how is this math used in science? And so part of our conversation afterwards, when Brenda and Sandy and I sat down together, was the one-step equation is what students do with density and speed. And the 7th grade photosynthesis equation. Brenda, help me out here. What else did we talk about with that? Anyway, so it's those kind of connections. So what we want you to do is, of course, Brenda's 9th grade. She'd have to know what the 6th grade science teams were. But that comes from conversation with your science partners. And excuse me, Denise may know that. I don't know.
I can look them up.
But you know, the idea would be that Brenda would be teaching or beginning to teach about the one-step equation and might relate it back. Okay, when you're in the 6th grade and you were solving for speed or density, this is what you were doing. That's the kind of integration that we want to see in your classrooms, that kind of linking. And in Tim's room, Tim made some kind of connection between math and science and stated it overtly. And one of his girl students said, "Really? Science and math are related?" That did.
Yes, okay.
Yeah, that's good.
And she was a smart girl too. She was a smart student.
She was.
So, yeah.
But it's like, oh.
But that's not, I mean, we've heard that before. That is not unusual, and that's our fault. Because we don't make those connections. It's the Las Vegas story all over again. What goes on in math stays in math. So make those connections. You're not teaching, the math teachers are not teaching the science, and the science teachers are not teaching the math. It's just making those connections with students. The students could be using, the math students could be using science data. Sherry and Bill do that a lot. So he would have conduct the lab, and then Sherry would do the data analysis in her classroom. And you know, there's a lot of ways that you can do this, but we're not expecting you to teach these other disciplines. We are expecting to use the other disciplines' proper language. So you're not saying simplify versus reduce. Tim had a great comment on that. He asked this one student who was, I think, struggling with it, and he said, "If I lose 10 pounds, did I simplify or reduce?" What a great example.
And what did she say?
He was a boy, wasn't it?
It was a boy. He was just mad because I separated him. But I asked him, if I lost 10 pounds, I hope I don't gain that back. So if I'm going to get it back, I reduced myself, but I'm not I would actually be changing. I'm not the same person. And so hopefully I don't get it back plus more. And he kind of chuckled. And then I said, so if we're simplifying a fraction, what are we making it? We're making it smaller, but it's also the same, so we're actually making an equivalent fraction. You know,
So you're simplifying rather than
Simplifying.
reducing.
You're reducing.
Because reducing implies a loss of something.
Right.
Yeah. So you're not
And-
really making it smaller, you're just simplifying it and,
No,
what?
Yeah,
you're making it equivalent.
equivalent fractions that, yeah,
Okay.
may or may not make it easier to work with.
And then, we got into some conversation, Browning and I did, because we do that a lot. And the idea of what is the difference between an equation and a formula, and in science, our equations have arrows, right?
Mhm.
In math equations, they have equal signs. So again, there's that dictionary kind of idea that we're using the same words but having different meanings in math and science. So as we are discussing an equation in math, I think bring up that idea, depending on what grade level it is, probably not fifth grade, that there's this difference.
Well, but you didn't finish the story. What do y'all call equations in science?
Formulas. A
Formulas.
formula for speed
Oh,
is distance over time, right? That's that has an equal sign, but that's not an equation, we don't call it an equation.
What equation?
If it's an equation, it's done for that.
It's a-
Okay, one at a time. What? Mark?
Oh, well, there's, the math reference chart for STAR, or does it say on the back equations or formulas?
It says formulas.
Formulas. Okay, so for the science one, it says formulas also, science formulas.
Well, some equations are formulas. But if it has an equal mark in there, it's an equation. They're equal.
Right.
But some equations are formulas
Formulas.
because they have been abstracted through computation, and we use them all the time.
Okay.
Okay,
Get that.
there's that abstracting through computation.
I was just gonna say, in science, the arrow actually means something. Because it means that a reaction took place, and you now have a product.
You're talking about chemistry.
Mhm.
Right, but you don't have an equal sign.
No, that's what we have.
Yeah, we have the arrow, right?
But there's the same amount of matter.
Oh, rounding in the midst of a problem, that was in Brenda, so Brenda, you want to address that when you talk about they were trying to
Oh,
round in the middle
right.
rather than at the end?
They don't like decimals. And so we were working an equation that had decimals in it, and before they ever got to the end, they were already trying to round it. So not everyone was having the same answer because someone rounded early, someone else didn't round yet. And I did not bring up the point that you don't round until the end, because then the sooner you round, then you end up skewing the answer.
Well, it seemed to me
So-
like that, I've seen some
But-
perfect examples that if you round in the middle, the difference in the two answers that
Right.
you end up with is probably, for me,
But they do not like decimals, so they were trying to get rid of it as quickly as possible.
Look, in building a bridge, that rounding error may be important.
Lori, you
Yes.
have questions? Scale factors and dilations, you want to talk about that, Brenda?
That was in Tim's class, so Tim, you got the floor.
My students had a problem to work on where, you mentioned it earlier, where they were gonna paint a wall. They had a scale drawing of a living room. And we had worked on scale factor and dilations and scale drawings for about a week and a half. And when I gave it to them, they just, there was some of my, in that classroom, you have to understand, there's 11 girls and one boy in that class, and then me. Some of the girls were like, I got this, and I was watching, okay, you guys are playing. Before by the door, the one that was sitting, the one that asked, so it's science and math related.
Raven.
She got,
Yeah, Raven.
well, Raven once, she worked through all of her, whatever was going on with her that day. But when we were going through and we were doing this, it was like, okay, at first they would not get it, so I had to come up with different ways to represent a fifth of a gallon of paint that they were gonna use to paint 90 square feet. And so I just quickly drew like a little cylinder and I broke it into fifths and I said, okay, if this little section equals 90 feet, what do all of these sections? And they were like, we need 8. 8 what? And they were like, 8 gallons? Or no, you need 8 fifths. Okay. So they finally got that, and then the other part was, I had to actually just draw out a rectangle of 1 inch. And I told them, this is not the scale, understand that. And right above it, I put 6 feet. And I've figured out why I drew it vertically instead of horizontally. I wanted all the rectangles to try to be the same size. But,
Plus they were ended up adding on.
and they add vertically.
Because when
So,
Tim was drawing that, he was drawing rectangle,
Rectangle,
rectangle, rectangle. And I said, wait a minute, they're trying to get length. Why doesn't he draw a rectangle, a rectangle, and a rectangle? Because you get length.
right.
So and maybe that answer, you draw it both ways. Or you have the students draw it
Right,
both ways.
so when I did that, because Raven was just like, I don't get it. And it's like, Raven, I know you're smarter than that. When I started drawing out those rectangles and represented it, she was like, 21. Okay, so how did you get that? It's right there. Right where? Right there on the board, you drew it, it's right there. And I was like, okay. What represents the 21 and how did you get the 21? It's right there.
He did a good job of not letting her get by
But,
with that.
and then
He pulled it out and pulled it out. He does a good job of
Mhm.
monitoring their sloppy language. He will often say, can you say that mathematically?
Yes, especially when they say 0.4. Can you say that mathematically for me? Because I don't understand 0.4.
Yeah.
But eventually she said, you're adding this and you're adding this and you're adding, and I was like, okay, thank you.
And even, having the students come up to the board or the
With
screen
that.
and, point to what they're talking
Right.
about and have them using that precise language. Because that's part of developing those writing skills too. Okay,
One of my kids corrected another kid, he was saying, that's 10.8, he goes, that's 8/10. I just sat there and went,
Yeah. My kids
And then he
do
was
that
like-
a lot now too.
okay.
Tim also had something about zero
That
pairs
led right into that.
and related it to protons and electrons in the atom, and these were 8th grade,
Eighth
that class,
grade,
right?
that's
So,
an eighth grade
that
class.
worked for 8th grade, so that was good. We got
Say
that
something.
one. Oh, integers, we were talking about whose integers? Was that-
Ashley, which is
Yeah,
the perfect
Ashley.
lead-in, because Tim
Yeah.
did just a little bit with 0 pairs, and then we went to Ashley, and Ashley?
Oh, yeah, that lesson. We are working on operations with integers, so I'm taking one operation at a time. And yesterday we did subtracting integers, so we used the counters, the positive and the negative, the two-sided counters. So it was just hard to get them to realize that, that minuendos that are total, even if you're taking away, if it was 5 minus 7. If you don't have 7 to take away from your original minuend, then you need to create those 0 pairs. And they were having a hard time figuring out why we add the 0 pairs. And they were just wanting to add 2 more to take away 7.
And she was using the
Yes,
counter.
we
Two
had
two color counters.
Uh-huh.
2 color counters. We were working with the counters first before we started putting the notes in our notebooks. So I did a lot of exploring with them first, and then they started to get it. It took a while.
And then she had them draw it, so she went concrete, pictorial, and then they went to the equation.
Well, next week we'll go Monday, because that was hard, just to get them to realize that they need to add 0 pairs to take away whatever. they
So
need.
Monday, you're including number lines.
Yes, Monday we're including number lines and.
Horizontal number lines, but then we were also thinking about vertical number lines, and that's where sea level
Yes.
minus temperature, minus degrees in temperature,
Because-
geologic time scale.
Because we were talking about sea level, when I introduced integers as far as opposites and absolute value. So, we were talking about using sea level to find the difference. So what is the difference between these two, sea levels? So we'll get into that on Monday.
Go ahead.
When you're introducing that lesson to your class, do you write your objectives on the board?
Oh, yes,
Okay,
yes.
so the objectives are there,
yes.
so they know what they're gonna be doing.
Yes, and my interactive notebook, I found online this really awesome, how to keep them extremely interactive and reflective. So they have a left side of the page thinking, which is their thinking, they rewrite basically the TEAC, the learning goal, because the TEAC has all types of big words and vocabulary that they need to know, but they need to rewrite it in a way that they understand it. So I have them rewrite it and tell me what they know about whatever they know that's in that TEAC.
And how can they rewrite something if they don't understand it? They do it at the first of the lesson.
Well, we talk about like the keywords like generate. Okay, what does generate mean? It means to create something. Okay, so what are we creating? So we talk through the learning goal.
Well, that sounds to me like it's teaching the lesson. I'm struggling with this, putting the learning objective on the boards here. That if you're going to teach it by inquiry, you're not gonna put the answer, so to speak. Sometimes the teachers don't tell you anything, you put them up there. But if it's inquiry, you have to write it in a way, you will learn how to do such and such, or, something like that, so it doesn't tell them what it is. But it would seem to me that if we're having them rewrite the text, their understanding of it, how can they do that if they don't understand it? I mean, do they rewrite it later when they do understand it? I don't know.
I think you were using it as a pre-assessment, just what do you know already?
Yes.
Okay.
Like,
And then,
because they're not gonna know, like, when we were doing multiplying decimals, like, they're not gonna know how to multiply it, they haven't done it yet. But I said, well, what do you know how to multiply it? Well, we know
Right,
how to
but is there discussion though? I mean, it seemed to me like if it's a pre-assessment, you don't do any discussion. You go into the lesson
Well, it's
teaching
not,
it.
it's more just a discussion between the class, like, what do we know about what's in the TEAC first? And then sometimes they don't know anything about the TEAC, and that's when we go back at the end and then we
Rewrite it, yeah.
So, but like
Yeah.
the multiplying rational numbers, well, they know what a rational number is, so we break that, well, we know, we taught that first. So, they would say fraction the decimals, so we would add, subtract, multiply, and divide, fraction the decimals.
So there's that kind of wrestling that you have to do about what do you write up for your learning objective. And I think the principals, there has to be a conversation with the principals. What does the district require? Does the principal understand inquiry and what should or should not be written up there? Now, some principals will require it to be written, but it's under a little flip thing, a chart or piece of paper, and it's not revealed until you get to the end where they are understanding what that concept is. So that, there's different ways of doing that.
Have it up already for them to see.
We have ours up, and then I actually asked Line to just give me a product. What is it, how do you know they've accomplished what they're gonna do? And then I can go through and I can see all day if they're teaching 4 different things, it's a 5th grade class, wow, they've used a worksheet all day today. And that's very quick that I can see it's on the board, with this worksheet we're going to, or filling in the blanks on this worksheet. And I'm like, where are my hands on, so I can go back and do that fairly quick.
We have a huge problem with our student teachers is